All right. I think we are pretty much almost ready. I do still need to get the camera on. Get this open. Okay, let me just get this loaded up and then I'll give a quick introduction and we will get going. Browser, screen. Let's go ahead and fix the focus. Like this. Go here. So I got a new PyPortal that I'm going to open up. That's what I'm going to be using today. Got full screen. Looks like it's focusing, which is interesting. Let's turn the light on. There we go. And yeah, usually I have to go and do this manual focus. Hard to tell with the bubble wrap. I think that's probably pretty good though. We'll fix it later if we need to. Okay. So let me minimize this in case we need to change the camera later. All right, quick introduction for folks that are new who maybe haven't seen the stream before. My name is Tim. I go by foamyguy online on Discord and GitHub. The Discord, the Adafruit Discord, and the live broadcast chat is the chat that's showing on the screen there, so you can join me there if you are interested in asking any questions or following along or sharing what you're working on this weekend. I'm always happy to see folks in the chat and say hi. So this week I will be looking at some new Displayio widgets, which I don't have pulled up yet. Let me go ahead and grab those. So let's say Cedar Grove GitHub. I don't know this user's exact name. Let's see here. Cedar Grove Studios is what it is. So this is community member Cedar Grove. If you've been hanging around the community for a little while in the Discord and on show and tell and stuff like that, they have been working with CircuitPython stuff for a little while now. And one of the things that they have made most recently is some Displayio widgets. And if you have ever caught this stream before, then you probably know that Displayio is something that I'm definitely very interested in and always interested in looking at new stuff that people are doing with Displayio. So today I'm going to take a look at the widgets that Cedar Grove has created. And then after that, maybe we'll get into some other stuff. I've got a couple other things I could work on maybe. I did get my my Ada box this week, so I'm pretty sure I have an idea of what's in there. And I haven't had a chance to play with the hardware that comes along with it yet, so maybe with some time that we have after taking a look at these widgets, I will open that up and kind of play around with those LED glasses, which are, I believe, what's in there. Sorry, I should have given maybe a spoiler warning. I think at this point, everybody either has their boxes or knows what's in there, though, so hopefully I didn't ruin the surprise for anybody. I definitely apologize if so. Yeah, that's what we'll look at. If we take a quick step back, even higher level introduction, again, if you've never seen the stream before, if you don't have any idea what I'm talking about, everything that I will work with on this stream is related to CircuitPython. So this is the main webpage for the CircuitPython project. You can find it at circuitpython.org. This is basically a version of Python that runs on these tiny computers called microcontrollers. There's a bunch of them in the backgrounds in the picture here. There's one of them embedded inside of this lightsaber toy prop here. And I also have a PyPortal right here, which is still in the package, so you can see what this looks like when you get a new one, but I'll pull it out just so we can see another example of one of these CircuitPython devices. So there's the, this one is called the PyPortal, and as you can tell right away, pretty much the main feature that this one has is this pretty nice sizable screen on the front, and this also has a touch overlay as well, so you can touch on it. I believe it's resistive. You can touch it and it can sense where you're touching, so you can use that for touchscreen interfaces and all sorts of stuff like that. On the back here, this main chip right in the middle, this is the actual microcontroller for this board. So this is a SAMD51. And again, you can run Python code on this to have it do things. You can hook it up to all sorts of sensors and lights and buzzers and switches and all kinds of electronical hardware devices. You can also, in this case, turn it on and draw stuff on the screen, which is what we'll be looking at mostly today. So yeah, let's do that real quick to wrap up. If you are interested in getting involved in the CircuitPython project, there's a couple of ways you can do it. If you do head over to circuitpython.org, there's a contributing link towards the top of the page here. And this is going to be a list of all the open pull requests on this tab here, and also open issues on this tab here. And these are great places to get started if you're brand new to the project and you want to get involved, if you want to help out with development. So you can find the PRs, you can help review them, check over the code. If you have the test device, if you have whatever device that it's for, so like this one is for the APD S9960, which is some kind of sensor, I believe. If you have the device, you can use it. You can test out the code in the PR. If you're interested in diving a little bit deeper, you can go to an open issue, and you could actually make a PR yourself to resolve one of these issues. And we also have this drop down here. You can sort by good first issue. If this is your first time doing anything like this, all the issues that are filed under good first issue are really good for folks that don't have much experience. A lot of the ones we have right now are for adding type annotations to our various CircuitPython libraries. So it's pretty straightforward. It's basically just looking in the Python code, finding the types of the arguments and the return types for the functions, and filling those in with Python typing annotations. So that's a good place to start. Another thing you can do if you are not interested in necessarily getting involved with the development is you can head over to Adafruit.com and you can purchase hardware from them. So Adafruit is a hardware and software company based out of New York, and they create all sorts of little electronic doodads, lots of the microcontrollers that can run CircuitPython. They create those and sell them. They also create lots of different things you can use with the microcontrollers. So little sensor breakout boards and every kind of LEDs that you could imagine. Buzzers and beepers and doodads and e-ink screens, all kinds of stuff like this that you can hook up to your microcontroller to interface with. So you can find all of those neat toys on Adafruit.com, and if you do make a purchase from Adafruit, you are helping support the CircuitPython project, because they are the folks that are providing the primary financial backing for the project. So they're paying a couple of folks to work full-time on the project, on the code for it, the libraries, also fostering the community around it, and all sorts of things like this. So they're doing a lot in terms of supporting the project, obviously, by paying the folks who are working on it. So if you purchase hardware from them, you are indirectly helping support the project as well. Okay, so like I mentioned before, here, let me organize a couple more things. Let's close this. Let me check in on chat. What is Dexter running up with this week? Let me hide OBS. Here we go. Audio level's good on YouTube. Nice, nice. Full of fun. Okay, sweet. Yeah, that's gonna be. I placed my order in pretty late. I was like right before they started shipping, or right around the time that the first one started shipping, I think. And so I ended up waiting a couple of extra weeks, but I did get it this week. I think on Tuesday or maybe Monday. I don't remember exactly which day, but I haven't opened it up yet. But I do have a pretty good idea of what's in there. My wife got one and ate a box at the same time. She opened hers, and I had a pretty good idea even before that. It's kind of, if you are involved in the community and you hang out in the Discord and you kind of watch what the new products are and what sort of libraries and things that all of the core developer team is working on, you can usually get a pretty good idea of what which products are new that they're putting a lot of focus into, and oftentimes those products are find their way into the Ada box. So, oh, nice, Dexter, you're working on Displayio on CircuitPython Raspberry Pi Zero. So are you running the build that Scott's working on? You're not using like Blinka Displayio, right? You're using the actual core Displayio with that build that Scott's been working on? That's really cool. That's definitely on my radar list of stuff to look into. I need to get set up with is it GDB? Is that the tool that Scott uses to debug those? I need to get that set up for myself. I've never actually done it yet. Oh, nice. Yeah, that's really cool. Yeah, I'm super duper excited about the idea of getting Displayio onto HDMI GDB. Okay, yeah, I haven't ever set that up yet. I need to do that actually for a different reason as well. There's a weird thing going on with the Pico with its NVM storage. I worked on a little NVM helper library a couple weeks back. I talked about it a little bit on the stream. When I first built that, I thought there was a bug in it, but it turned out that the Raspberry Pi Pico actually has a bug with NVM. Sometimes when you try to, is it read or write? I think it was write, but I'm not 100% sure. Sometimes when you try to use the NVM though, the board ends up crashing, and it's a pretty hard crash. It doesn't give a stack trace or anything like that. So I need to get that debugging hooked up in order to see what's going on in that case and be able to add some information to an issue or make a new issue if one doesn't exist. Before I get launched right in, I am actually going to step away for just 1 minute and put up a little blocker to block the sun that's coming and hitting my eyes right here. I'll be right back. Okay, much better. So maybe if we have time after looking at these widgets, maybe before I dive into the AdaBox stuff, I will take a look at GDB and see if I can't figure out how to set that up. That's probably it's definitely something on my list of things to do. Might be a fun thing to do on the stream. That way there's like a video record of it. I could go back and reference it if I need it. That's one of the things I've found about streaming. I've been streaming for a little while now, once a week. And it's really nice when I work on something on stream. I'll find myself, going back to watch that portion of a stream to, kind of jog my memory of what I did and how I did it and that sort of stuff. If if I don't touch it again for a little while, it's nice to have that record I can go back to. Okay. So, like I mentioned, the place where I'm going to start out, though, is on this new PyPortal, and we're going to check out Cedar Grove's new DisplayioWidgets. And so probably the first thing I'm going to need to do is update this PyPortal, I'm guessing. This was off the shelf at Micro Center. My suspicion is it's probably been there for quite a while. And so this probably has CircuitPython, 5 or 4, maybe even something relatively old. That's my guess. But let's take a look and get it updated if it needs it. We'll go Device Workspace. New window. Check the boot out. Yeah. CircuitPython 4 Beta 5. That's how long this device has been on the shelf there. So let's definitely go and update that. So we'll head here. We're going to go back to circuitpython.org. On the downloads page on circuitpython.org, we'll be able to get 7.0, which is the current release. So let's go PyPortal. There it is. Download. I ended up getting a new PyPortal because the one I had is embedded in that Etch-a-Sketch project. That's another thing I worked on the stream a couple of weeks back, maybe a month or two ago at this point. And I really like the Etch-a-Sketch. I don't really want to take it apart. So I ended up getting a new PyPortal. That way I have another one that I can use to test and do various things unrelated to the Etch-a-Sketch on. So we need to get this into bootloader mode. If you are familiar with CircuitPython, you'll know the way to do that is just double-click the reset button. So there's reset on the back. We'll double-press that. The LED will turn to green. Can't see it too well there in the camera, but this little LED is now green. It blinked red for a minute, and then it turned green, so that's how we know we're in bootloader. The other way we know is on our computer. This device now is connected as portal boot. So we're going to copy the UF2 file, paste it on there. Yes. Yeah. Ain't that the truth, huh? Best that 2019 had to offer with CircuitPython 4. Okay, so we paste that, and then automatically we see that CircuitPy comes back. Go to here now, and our boot out automatically updated in PyCharm, which is really nice, and it now shows CircuitPython 7.0.0, and this was built about a month ago, 2 months ago, I guess, 7.0. Maybe we should grab, is there a newer pre-release? I guess there is, right? 7.1 beta 0. Let's do that, actually. I usually run with the beta on my devices to try to help troubleshoot anything. I just kind of autopiloted to the release version. So let's update that one more time, actually. We go here, double click again, double click, and we'll just paste that 7.1 version instead. So this is one of the really cool things about CircuitPython. Again, if you're new to the project, if you haven't messed around with it too much, it's really, really super easy to install different versions. Just double click the reset and copy a file onto a thumb drive, and that's all you got to do. So it's real easy to like switch between different versions to try different things out or upgrade your devices. Sometimes you may have to update libraries as well, especially if you're making a jump like this, like CircuitPython 4 all the way up to CircuitPython 7. Certainly, very likely that probably all the libraries would have to get updated. However, this, no, I guess it does have a couple libraries on it. I was going to say it probably doesn't have any because it's brand new, but it looks like they did package it with some. So there are some on there. You know what we could do to update all the ones there is and in fact you can see, oh, they're all MPY files. So you can see the fact that we need to upgrade. There's probably a few reasons we need to upgrade in this case. Probably the APIs for various things in the core changed between version 4 and 7. So the libraries would need to update to use the new APIs. The other problem is that the libraries get kind of compiled with this MPY cross application or utility. And the version of the MPY compilation changes every so often. Whenever we pull in changes from MicroPython, there's a chance that the MPY format changes as a result of those MicroPython updates. So that's definitely happened here as well. We can see now that we're on 7.1.0, and this would have been the same on 7.0.0. I didn't actually see it on the screen, but I'm sure it would have been the same. Our MPY files are now incompatible. One really cool tool that I like to use to update these is called Circup. If you've never used Circup before, definitely check it out. But you can just do something like this, Circup update, I think. And I'm pretty sure this will go through and find all the libraries and then update them. Yeah, so we found 10 modules needing an update. Warning, it doesn't match. It's updating as required. Do I want to update? Yes. So we're just going to hit Y for yes on all of these. There's probably a flag I could have passed to just do them automatically. I don't know for sure, but this is pretty easy. Okay, now we're all updated. And now it should go back to running. No module named PyPortal, actually. Interesting. CodePy line 3. So did PyPortal, was it one of the ones in here? Something went wrong. Python bundle. Yeah, so PyPortal, it's not a single file. It's probably a module. Oh, weird. We got this file that doesn't know what type it is. And I can't open it. Weird. Yeah, so that file doesn't exist anymore. So it seems like when I try to update it, it deleted the old one, but it was not able to successfully find the new one. Let's do a refresh here. Refresh, where's it at? Refactor. Reload, that's what it's called. Reload from disk. There we go. Okay, so now it's gone. So that's the actual state of the device. So why did not installing work? What if we just try installing again? that doesn't work, then we'll investigate the bundle a little bit. Circup install. Okay, so it found a bunch of stuff. It found all the requirements. PyPortal. Seems like that worked. Yeah, there we go. So maybe when you use Circup, if you used to have a single file version of the library, but the new library is a multiple file version, like a directory with a bunch of stuff inside of it, then the update from Circup does not work, possibly. It's like assuming that it was going to be a single file again, instead of recognizing that it changed to a module. Is that possibly true? We should probably verify that at some point, and then maybe open a open a issue on the Circup repo. Because if that is actually the case, then we would want to get it fixed, I think, inside of Circup. Do I want to do that real quick? Yeah, why don't we go ahead and let's verify that real quick. So, you know, I sometimes run down rabbit holes and stuff. I love me a good rabbit hole to crawl through for a little bit. So let's try to check on that if we can. CircuitPython, PyPortal, GitHub. Let's go find a very old version of this that was a single file. Let's put it on our device. And then let's run Circup update. So one problem is it's going to be hard to tell when the change happened. Huge refactor. Ah. Okay, maybe I was using the wrong terms. So it got turned into a package, which is a directory. So I guess module is actually the name for the single one. So this release here would have been the first time that it's a folder. So this release here should be the last time it was a single file. So, and of course, there's no 7.0 for that, because it's so old, but that's all right. We don't really care that the MPY files are going to be different. Really, we just want to get a single file version of it, drop it on there, and then try Circup. So here we go. MPY file, back to device. Let's delete this. And let's paste this one, lib. Hey Dexter, if you're still there, what all hardware do you need to get that Pi set up? I've got a 02W. Do you need like a USB serial converter, something like that? Do you need any other kind of special hardware? Obviously the HDMI cable. Anything like breakout wise? Okay. We have PyPortal now. And probably this is crashing again. Find yep, incompatible, so that's crashing. USB to serial converter, MCP 2221A, and the HDMI display. Okay, yeah, that's not too much. I think I have one of these. I think I'll know it when I see it. Oh, maybe I don't have this exact one, I guess. Doesn't show a, oh, I'm not signed in. I'm not signed in. Let me try over here real quick. No, I'm not signed in on this one either. Alright, well, I don't want to go track that down and sign in right now, so we'll just leave that. I'm pretty sure that I have one of those. One of the really nice things about the Adafruit website, if you are signed in, it will tell you. There will be a banner up here that tells you if you purchase this and when, which is nice to know if you have a certain thing without having to dig through your parts. FTDI dongle would work as well. Oh, okay. Yeah, I definitely got one of those. Okay, so we put the single file. We go back to here. We're connected to REPL now. Or serial, I guess. Circup update. Can we pass the single one? Adafruit PyPortal. Update options. Got unexpected arguments. Circup. Help. Can you update a single one? Install the named module. List. Shows all out of date. Show. Lists all the things in the bundle. Uninstall. Update. Use all to automatically update. So there's our flag for getting rid of the yes, no. Looks like you can't specify a single thing to update. I could try install. Circup install. Already installed. And this did not change. Yeah, this did not change. So let's do update again. Format doesn't match. Updating is required. Yes. No such file or directory. Yeah, it's totally checking. It's checking the existing library file to determine how to copy the new one in. And since the existing one has the MPY extension, it's not finding the new one because the new one does not have the extension. The new one is inside of a folder, and then there's a file inside of there with the extension. So now that we've discovered this, let's make a quick, let's open a quick issue on the circup repo. So I appear to have lost the Twitch chat. Let me open that back just in case anybody tries to say something over there that we want to see. I want to keep track of that. There we are. Okay. And yeah, volume is off on that one, so I'm not going to hear myself good. So let's go to circup repo. Circup. Python library updater. Let's go to issues. Maybe there's one already. Let's check. Third-party bundle support. I think Neardoc was working on this. Not sure the current state. This one might be resolved already, though, truthfully. I want to say Neardoc got that working. Handle modules. Yeah, there is one already. Yeah. Yeah. Okay. Okay. We'll just leave a note that says we found this as well. And yeah, maybe we'll look into that at some point on the stream. It seems like a fun thing to try and solve. But I do want to get back to where I started, which was Cedar Grove's widgets. So we can go ahead and install PyPortal. Not really sure if we're going to need PyPortal, but we can install it. There we go. Code. This is like a PyPortal test or something. F6. PyPortal test. 1 second, I'm going to check on something. But I heard a strange sound. CodePy portal, so let's make a new code. Code. Oh shoot. Not have done that. With that canceled. I noticed if I don't select Python file, then it starts to associate code.py, even if I do name it .py, it starts to associate it with a text file, and I gotta go inside settings somewhere and tell it to reset, basically. So I'm also gonna clone Cedar Grove's widgets repo. Copy. Git clone widgets. I'm gonna name it widgets. I'm gonna rename it move widgets Cedar Grove widgets. Okay. So we have Cedar Grove widgets. So I'll open that. I think I could just overtake this. Yeah, overtake this. Open Cedar Grove widgets. New. Okay, now we will look at examples. Let's look at foamyguy first. So I wasn't familiar exactly where this came from, so it's called, let's say in the docs there, a 6E5 triode indicator. I was not actually familiar with what this device is. Okay, yeah. The widget that Cedar Grove made definitely looks like this. I wonder if we can see it in action somewhere. There we are. Oh wow, this is like some kind of fancy light bulb in there. Look at that. Turn it on, turn it on. Gives you a nice green glow there. Gotta be coming pretty soon, right? There we go, okay. It's got a sort of green light coming out of it, and then it's got a couple of lines, which I think are indicators of a level of some sort. Father had an old radio that had one. Nice. Yeah, I've never actually seen one before. Well, I don't think. I mean, it's possible I've seen it on something and just don't remember, but... Okay, so these kind of gets more or less filled in through the semicircle. So it's almost like a circular progress bar, but it's mirrored. Like a circular progress bar would start on one end or start somewhere and go around to the other end. And, you know, essentially like only one end of the filled in part would be getting bigger. Whereas this, it looks like it's mirrored. Both the, you know, beginning end, if you want to call it that, and the ending end both get bigger. Crazy. How does this thing work? This is like Super fancy light bulb. Tuning indicator. Yeah, so it's definitely increasing and decreasing the size of that gap there. And then I think they can overlap as well. So it might not be a gap, it might be a overlapped one that becomes like double bright in that portion. This one's not changing too much, but it might be just the camera and the angle we're at. Interesting. Cube tester. All right, I'm gonna look at one more real quick. I'm interested to see it just like straight on, real big. Oh, there we go. Yeah. This is exactly what I was looking to see. Wow, what a neat little device. That's how it plugs in. This person's making a tester for them. Pretty cool. Oh wow, they even shared the whole circuit and everything. Nice, this is a good little video. Got it plugged in, it's got a knob for opening and closing. Like it's got a spot for a second one as well. Huh. So what does it normally measure? I'm sure if I watched this video more thoroughly, I could probably get a better idea. Is it measuring resistance, or I don't actually know what it's measuring? It's really cool though. So now that we've seen the real one, let's load up the one that Cedar Grove made. So Magic Eye example. We'll need to copy the widgets. Cedar Grove widgets. So we'll need to copy this to the device. And this code to CircuitPy. And I'll pull the camera up. Let's go this way, this way. Shrink that down. Okay, we'll save this. We may not have, there might be some libraries. Yeah, display shapes we need. Let's install that. Oops, I keep doing an X. I think the lines are just an artifact. The wedge is the actual indicator. All right, so I got a couple beeps out of it. Oh, there we are. Nice, look at that. So it, now it's overlapped. Nice. And so, let's see, what do we set this with? Is it just a float, or? That's where our beeps came from. It's pretty straightforward. We make a Magic Eye. We select a size. Wait, 55. So the size is a proportion of the screen? Is the size a proportion of the screen? So if we change this to 1.0, would it be the entire screen basically? Memory allocation failed. Too big. Shapes. Making a circle. I wonder if it could use vector IO. Let's see if we take off the second one also. Still too much. Should have looked at the. Oh, you know what? We're done. We're missing. Yeah. Anyway, we got the memory error anyway. So let's try not all the way to 1.0. What if we just do 0.8? Is that still too big? So it was 0.55 when I started. Nope, still not there. Let's try down 7. I guess maybe vector IO might not work if internally the widget is display group. Okay, so it holds its own group. Does it extend group? Let's take a look at the way it's coded. Class palette. I'm not sure if it's I'm not sure if it's best to reuse the name palette since Displayio already has palette. Does not extend group. It just has a group. Doesn't extend anything. Yeah. Size of the display. Size of the display. I think this is the size of the eye widget, though, really, more so than the display, right? Donut mask. Oh, wire shadows. So those two little lines going off to the sides, those look like, in the real ones, maybe there's a couple wires there that cast a shadow. Interesting, there's so many groups. I wonder if it could get away with using one group and putting the rest of the stuff just in the one. If display. Display size. Should this be is instead of in? Oh. The display size is a tuple. Did I change display size or I just change size? How does this work? Instantiate the object. It's a hierarchical group consisting of subgroups for target, anode, eye, and bezel cathode. Display size in pixels is specified as an integer tuple. If the display size tuple is not specified, an integral display is listed. Oh, and built-in display, I think that means. Then the display size tuple will be equal to the built-in display height and width. Target anode center XY. Normalized. So this is almost like anchor point and anchor position. I wonder if Cedar Grove has seen Displayio layout. So there's a widget. There's a widget class in Displayio layout rather, that you can extend, and it gives you some of this behavior kind of for free. You don't have to re-implement it. Because I guess probably there will be a property center in here, and there will be the math to place it. Or not a property. So maybe you can't change. You change the location after you create it. That one did go to the center. Is this a tuple also? Let's say 0.5, 0.1. This should move it up, I think, to the top of the screen, but still centered horizontally. Oh, right. So now the center of the donut is on 0.1, but that's not enough room to be able to see the top. We'd have to go lower than that still. Yeah, still not quite there. Maybe 3 would do it, or 3.5. There we go. Now it's on the display still. And it seems like size is also relative to the display. Like we have 0.5, which is making it take up half of the display in width. But it's in the center, so it's like 1/4's over here, 1/4's over here. 2/4 make up the diameter of this outer circle. Bezel color. Black. Can we set an arbitrary color? We would have to choose one of the ones that exist in that palette, right? Oops. We just say like red. Can, okay. It does. Well, okay, it didn't get bigger, but because it was black, we couldn't see the bezel before. And now we can. And so now the bezel is off the screen a little bit. That does make sense. Size, normalized diameter. This would stop popping up. Relative to the display's shorter axis. It's the longer axis though, isn't it? Because we have 0.5. And we're definitely taking up more than half. So the smaller axis would be this one, the height, when it's in this orientation. Oh, but we're not on 0.5. We're on 0.7. So that was probably 70% of the height. Yeah. Because this looks like 50% of the height. Definitely not 50% of the width. Okay. The host displays integer width and height. So it would need this in order to use the normalized values for size and location. It needs to know the display size. And bezel color, which we played with already. Yeah. 480, 320. Yeah, so you can leave the you can leave out the 480 by 320 if you have a display, like a built-in display. So I could probably just cheat it though also, right? Like I could tell it display size. I could just tell it something wrong, right? Like if I told it 180 by 180 and still 0.5, it will end up being 90 pixels wide. I think 90 pixels wide. And this will change with this, right? So if I go 240, 240, it's going to be bigger. Yeah, okay. And so when I didn't pass it, it just took the screen size, which I think on this one is 320 by 240. Interesting. I kind of like the way... I do kind of like the way this works. I think some folks might want to just use pixels. But I guess if you do want to just use pixels, you could always go... So like, let's say I wanted to make this, regardless of what size the screen is on, let's say I wanted to make it, you know, 175 pixels square. I could just go 1.0 and 175 here and 175 here. And then essentially I have declared the size in pixels. Yeah. The center gets a little bit weird if you do it this way. It's like if I still wanted to center it in my Pi portal, then I would be a bit out of luck. Because it's now centered based on thinking this is the display size. So my guess is it's got like an invisible 175 by 175 box that's like right around here. And it's putting it within that. We still wanted it to center on the Pi portal. I guess what we could do is we'd have to find the ratio, right? So we could do 240. No, we could do 175 over 240, and that's 0.729. So we could go back to default, and then here we could go 0.7, I'll just call it 7.3. And then back to 5 and 5. So this should be roughly the same size, but centered. Yeah. Ran out of memory with 4.5, or 5.5 rather. Yeah, the bigger screens are tough. Anything that needs a bitmap that is taking up the whole screen, it gets to be tough. Sometimes you can use scale as a trick for that. Like so we'd have to scale all the groups. Doesn't look like there's immediately an easy way to do it, since the only one we can get back out of it is the display group. Yeah, so some of this math that's in these, well, like this one, display to pixel, maybe not, well, no, not ortho. This is to do with the curve. This, I think, is the same math that's in the widget class, though. If you override widget, then it does some of this for you to convert proportional values. So I think if you wanted to get a 0.55, if you cut that in half, if you do 0.275 for your size, and then if you came in here, which right now you'd have to edit the library, but if you came in here and did scale 2 on all of these, it'd be maybe more pixelated or whatever by a little bit. Probably not enough to notice that much, though. Although this might throw off the math. I don't know if this will actually work. If we did scale 2, if we did 0.275, is that right? Yeah. And then leave the center, and then let's do your display size. Display size 480, 320, comma. Do I run out of memory for this? Ooh, I gotta... pronounce, it's not drawing correctly, though. So yeah, that's not... that's not gonna work quite how I thought. Display group. Oh, okay. Maybe we could actually. Let's... Where's display group? display. Okay, display group returns image group. An image group gets the rest of the groups. So we can do this without going inside, right? We could get rid of these. Save this back. So I should get memory error now. I mean, my device has roughly the same memory as yours, which... Oh, no, I won't because I did 0.275, of course. So 0.55, I would get the memory error, though, probably, right? Oh. I managed to get it. It might just be a different amount of memory, though. Depends on what device you're using. We could try to push it. Let's see where I end up running out. Okay, now I ran out of memory at 6.5. So now let's say if we do half of that, 325, and then we do foamyguy1.displayGroup.scale equals 2. We just scale the one display group. Everything else is inside of it. No, we don't see it anymore. I suspect this is probably thrown off. Would we need these to be cut in half also? Yes, that's what it is. We need those to be cut in half also. And in this case, it's actually kind of off the screen. I could go even smaller. And that would get it closer to on the screen. Or not. Let's say 1.5. There we go. Yeah. So it does get a little pixelated, right? Because now everything that would have previously been a single pixel is now a 2x2 square of pixels. So like, you know, the edges of the circle in the circle here, they're a little bit more jagged than they would have been if it could render at full size. But this does allow you to like get one, you know, that size at least, as long as you're okay with that jaggedy edges a little bit more than it would have been. I wonder if it would be possible to use vector IO circles. Oh, I didn't want to go inside that. I wanted to find its usages. Nice. Got it scaled, sweet. So let's find where we make circles. Larger stroke values. Not sure what that means. Component mask. Still none. So one thing that might make it hard is vector IO circle. I don't think it has outline. So I think the only way you could make an outline is by making one circle that's bigger and then another circle inside of it that's smaller. And then it would look like an outline. But at that point, I don't know if you'd actually be saving memory or not. Because then you need two circles instead of just the one with the outline, basically. The rectangles, maybe? These rectangles on the corner, I assume, where rectangle comes in. Paris. Parsis. Is that those things on the bottom there? Oh, no. Something to do with this part. Okay, so this is a triangle. And then there's a rectangle below the triangle. Slow this down a little bit. It's trying to go awfully fast. Let's do this. So yeah, it looks like to make the indicator at the bottom, I'm guessing this top part that we're still seeing, this must be where it's using triangle. And the part that is not filled in anymore below the triangle was the rectangle that I turned off by commenting out. Oh, there are two wedges actually, wedge A and wedge B. Oh, bezel group. These are the corners. This will turn off one corner. Need to scale the lux from BH175. Simple IO. I think Simple IO has a function for doing that. Map function. In map range. Yeah. This does that. If you're interested in having a library that do it for you instead of doing all the math yourself. Simple IO, you can import it. You can call map range. You give it the original. You give it the value, and then you give it. I don't know which order it's in, but you give it the range of the real values as they come from the sensor, and then you give it the range of the outputs of what you want. And I might have got those backwards. I don't know which ones are the real ones and which ones are the ones you want. The docs probably will say. Or maybe these comments, I guess, imply it. Yeah, these comments imply it. That the second pair is the new mapped values. The first pair then must be the original range. But this will do the math for you. So if your sensor is like, 0 to 1 or 0 to 255 in this case, you can map it down to 0 to 200 or up to 0 to 200 if that's the case. Nice. So let's turn our rectangle back on. Y, width, height, fill with eye color. There we go. Now this part's working correctly again. So this must be drawing a rectangle down to basically between the bottom of the triangles that we saw here and all the way down to this line. So actually, if we have the tarsus on and we turn back off the wedges, we'd probably see that rectangle peeking out the bottom. I guess that's probably why those wedges in the bottom corners are there, right? We turn this back off. We see the rectangle peek out. Yeah, there it is. So those wedges basically hide that rectangle. So the wedges could definitely be vector IO shapes, I'm pretty sure. Maybe some parts of this could be vector IO, and that might end up saving a little bit of memory. It'd be worth doing some tests. It'd be worth trying to make a circle that looks like it has an outline using vector IO, and then see how much memory it uses, and then compare it to a circle from Display Shapes that does have an outline just built into the API. So with vector IO, we'd make two circles, put one on top of the other. And then with Display Shapes, of course, we just create circle and set the outline to true, or a color, I think you set it to. It'd be worth seeing if vector IO uses less memory. If so, it might make this able to go bigger before it runs into the memory error. But anyway, this is a really cool widget. I wasn't used to, or I wasn't familiar with the actual physical component that does this, but looking at it, it seems pretty cool. And I definitely like the implementation in Displayio of it. It's always cool to see folks bring kind of real world sort of analog type outputs and, you know, digitize them and make a virtual one with Displayio. I always am happy to see that kind of stuff going on. So this is really cool. So I put everything back. And so when you set the value, you call plot IM. And then this is what takes the 0 to 200. Is that right? Positive floating point value. Okay, so you can do 0 to 1 if you do floats. But you could also just do signal value. Does it always take floats? Is this dividing? Oh, it's okay, it is dividing them. 0 to 200. So you can basically, it's basically 0 to 2. I don't know if you could go above 2. Try it. What if we turn all this off for now? And then what if we just set it once? So 2.0, let's see what that looks like. This will be, I guess, like overlapping maybe? Plot I. Yeah, this one's overlapping. So can you overlap farther? Can I go 3.0? Will that just overlap more? Or is 2.0 the max? Okay, it didn't crash, but it doesn't look like it changed either. So 2.0 seems like probably the max. This will also be overlapping, but not as much. Yeah. And then this, I guess, would be no overlap at all, but also no, like, dark zone. Yeah. Well, single pixel of overlap, basically, which might also actually be a glitch from scaling. In the original scale, maybe this doesn't light up that pixel. I'm not sure. We still get it there too. So where can we, if we can get it to like exactly filled but no overlap? Not quite 90, 97. Close. We already saw 99, so if 98's not it, then we probably can't hit it exact. Yeah, that's back to overlap. I mean, we could try in between, but my guess is we just can't hit it exactly. And again, it could be the scale. Might be possible to do it on the one scale one. We still got the little gap there. Let's try 1.0. Nah, it still has a line. Doesn't maybe come through in the video quite as well, but it does still have the line there. So that looks like the intended behaviors. 1.0 provides you basically the 1 pixel of overlap. Okay, so this is pretty cool. I'm going to take a look at the other one as well. There's a couple, there's at least one more. So there's a scale widget. So let's go back to here, scale example. Let's grab this. Throw that in CodePy. I should have pulled the camera. Let's see what we got here. We're missing a font. Brutalist font. Is that in the repo? No. Did it get declared in here? No. Let me look at the backtrace. $67 inside of scale. Oh, it'll try Open Sans 9 as well. But we don't have fonts? Ah, they are in here. Just take fonts all together. Copy and paste. I'm not asleep. Not sure the range. Flashlight goes up to 650 lux. Plot sensor.lux over 400. Nice. Yeah, that gets you down within the 0 to 2 basically. Nice. Yeah, if you sorry, music paused here. Let me put that going. If you're able to, I'm sure Cedar would be happy to see that in action. If you can snap like a short video or a picture or something of that hooked up to the sensor, I bet you they would be pretty stoked to see people using it and hooking up. You could put that in like show and tell room in the Discord or something like that if you're interested in doing that. So let's see what the scale does. We should have the font now, right? Is this just working? Oh yeah. Oh, okay. So this is like a... Oh, it's like a weighted scale. Interesting. Okay, so you you would put something on the top of this here. So you could use this maybe like with a sensor that measures weight, which would be, I guess, a pressure sensor. But not air pressure. More like this. Yeah. Interesting. If you, or like this, a force sensitive resistor. Yeah, this is, I think this is the one I was thinking of. So you push on this thing and it knows roughly how hard you're pushing, basically, or really what's happening is the harder you push, the more it changes the resistance value. So you can discern how hard you're pushing based on the resistance that comes out of it. So this would be a cool thing to pair with this scale widget. You could plug in one of these, and then when it gets pushed harder, you could make the scale, go up with more, weight, essentially. Yeah, I think it's probably the same thing. It just doesn't have time.sleeps, probably, right? If we did something like this in here. We'll get a lot less spastic, I think. Yeah, looks a little better there, at least in terms of not jumping around so much. Probably still speed it up even, maybe. Honestly, 0.1 or 0.2 might have been enough. If it were hooked up to a real sensor too, theoretically the values would not be changing quite so fast. Oh yeah, that's pretty smooth there at 0.1. So it's doing two things. The needle's going around, and also the top is getting pushed down. Does the second needle ever go up? Did that needle start changing to red there? Oh. A little bit back to spastic here. These ones are random though, maybe. Yeah. These ones are random. Which makes sense then why it's super twitchy, because like if you had it hooked up to a sensor, you would never jump randomly around like this if it was hooked up to a sensor. You'd always be going like up or down relatively smoothly. But just going random, then it's just gonna hop back and forth without going there. If you wanted to keep the random but make it less twitchy, one thing you could do is like select a new random number and then use a for loop to change it to some of the values between the current value and the new value. So you like take steps to get to the new value. It would take longer. You'd have another for loop inside of here. But then it would like, you know, glide to, it is turning red. It would like glide to that new value instead of just jumping directly, which would make it less twitchy. This is pretty cool as well. I think it would be cool to hook it up to something like this. I don't know if I've got one though, so I'll have to pick one up. Flexible. Well, I don't care if it's flexible, I guess, actually, but force-sensitive resistor. We do. Whoa. Nice. I do have some of these, maybe. So I'll have to find one and hook it up to this, because I think that'd be a cool extra example for this one, since it's like basically a scale as a component. And so I think there's a couple more. Let's look, let's take a quick look through some more of this. So these are the two that are, you know, quote unquote published, basically, like done, according to Cedar Grove. But there are some more in development, which don't have examples yet, it looks like. There are a couple more widgets. Would be center dot setter. It's commented out, so it doesn't matter, but I think a property is fine too, though. For should this be a function, I think a property is better. Because like X and Y, which would be the other way you could move this, those are properties, so. An anchor point and anchor position. If you extend widget from Displayio layout, then anchor point and anchor position, those are properties as well, I'm pretty sure. So let's see if we can get this one to work, bar graph. So I guess let's take these, all of these, copy, and let's put those in the library on the device. And then let's see if we can get this to initialize. So I guess I'll leave some of this. What all do we need here? I don't need random. I'm not going to do any randoms. Analog, simple IO. We can take the tones out. Scale. So we're going to get widgets.bargraph. I'm going to do this one next. Bargraph. Import bargraph. Don't need to play the tone. Okay, set up the display. I don't need to change the brightness. I don't think I need to change the rotation. Play group. So we'll basically create the bar graph, create bar graph, and then append it to display group. Hands, show the group, don't need the tone. And I'll start with just pass in here. and we'll change it after we get it running. We can set the value to something else. Okay, so we're creating a bar graph. We need units. Yeah, so this one does say still in development, right? So the parameters are not all documented yet, which is totally fine. Units, center, size. Let's leave defaults for these things and see what we get. Whoa. Mickey Mondes? Looks like this is decibels. This is like meant for measuring sound. Which makes sense. You could see this kind of thing on a stereo. I have a guess as to what this looks like. I saw a picture in a PR shapes in here. Cedar posted a picture of this. Yeah, I think it's gonna be this thing, which is pretty cool looking. Which you definitely, that's the kind of thing you'd find on like a stereo. So let's leave the defaults. Let's go bar graph equals bar graph defaults equals display group append bar graph. See where that gets us. Layer must be, oh, okay, so it'll be not bar graph directly, but bar graph display group. Probably that's how the other ones were. Yeah. I would recommend unless I am misunderstanding some part of the way these works, which is totally possible. But if I'm not misunderstanding anything, I think it might be good to extend group on these classes. Like even for the ones we looked at before, those classes, they could extend group and then they would not need to keep the like variable, you know, on the class, like self.something group. And then you would be able to just initialize it as bar graph and then append it to your groups directly without having to say like this display group, which is what we have to do now. It's not that big a deal, it just changes the API up a little bit. But I think a lot of the widgets that we do have already work that way. They will, most of the widgets I've seen, they'll either extend group, like if they have multiple components that go together to create the full widget, they'll extend group. Or if they don't have multiple components, if they just have like a bitmap essentially with different stuff drawn in it, then they could extend tile grid, and then the tile grid can get associated with the bitmap. But tile grids can be appended to groups as well, so it still allows that same API where you can just append the object itself to the group and then it'll show on the screen. So we are getting we're not seeing anything. I guess this is probably because we don't have any value, right? We need to set the value higher, which is units maybe? Seems like this must be units. One thing I notice, these are importing, these are trying to use pi and cosine and sine. But they're not imported. Maybe they're not called, so it's not going to crash. Yeah, nothing found. So my guess is probably Cedar just copied the scale or the dial or something when they started this one. Just never cut that part out yet. Let's try changing units. We go here. We could pass it when we initialize units. 10. Oh, there we go. Maybe that's too many. What if we do units 1? Okay, so 1 unit is 1 whole bar like this. So how do we set the value though? Origin, center, size, range, mode. Chips? No, chips, this is a group. Range. These get filled as black. So these are our little rectangles. Show signal. Yeah. So we call show and we pass the value. So units 1 bar graph dot show 4. Will this fill in 4 rectangles? Oh, no, this goes all the way. Which probably has to do with the range. Full scale 10 bars. So 4 is above 3, which is our max. So if we did 2, we would not fill in all the bars. No. So 0 does 1 bar. -10 does none. -20 also does none. 0 does 1. 1 does full. 0.5. 0.8. Okay. It looks like we're expecting a signal between 0 and 1. Yeah. So if we do units 2, do we just get a double long one? Or do we get 2? Yeah, we do get a double long one. That's cool. So is there a microphone on the Pi portal? I don't think so. There's a speaker. No microphone. The clue? Does the clue have a microphone? does. So why don't we try... Let's try getting the sound level from the Clue's microphone and hooking it up to this. So I have a Clue here. I'm going to plug this in. Hold this wire down. And let's try this out. I'm going to copy all this code. This is not a Clue. I'm going to close this stuff. I'm going to paste this back. It's going to crash because I don't have the library. Copy this. Yeah, for sure. Thanks for hanging out, Dexter. See you around next time if you're able to watch. Scale already exists. That doesn't seem likely. Guess, yeah, override it. Yeah, it doesn't exist because it's not there actually, but nice try, PyCharm. Okay, now we got it there. And now we need the in development ones too. Development ones. Copy these. So this should stop crashing now. And yeah, it's actually drawing on the screen as well. There it is. So we need to figure out how to get the microphone on the Clue. And I don't know if I've ever used it before. I guess I did one of the ULab, microlab. One of the microlab examples that I worked on maybe a month or two ago used the microphone. But I just copied all the code for that. I don't actually know how it was set up. Let's look in Learn Guides. Maybe there's Clue. Mic. So this is giving just a level. So this library, maybe this library has easy API for this. CircuitPython Clue GitHub. We could, of course, like just get the microphone by itself and initialize it. Maybe this library is not going to expose it actually. What let's say in here which thing is the microphone? Like what kind of microphone it is? PDM microphone. MP34DT01-M. MP3 for... This doesn't say anything about MP3 for D anything. Okay, here's the thing by itself. Okay. Here we go. Okay, it doesn't need a library. It's making a PDM in from audio bus IO. So let's go, I guess. I guess we could just paste some of this stuff into what we've got. We're gonna combine them anyway, so. Some of these we have already time board. Oops. Here we go. Helper functions. So we need to set up the mic. We need to create an array to hold the samples. We'll need to find the pins, which this told us. Microphone data, microphone clock. Named very well. So which one is which though? So they have microphone data going to D12, which is the second one they pass. So we're going to change D12 to microphone data, and then TX must be the clock, microphone clock. Okay. Now, record samples, length samples, magnitude. Let's do this. Out of here. Record the samples. Run it through this helper to get the magnitude, and then print the magnitude. Okay. Yeah, so it's getting louder when I talk, is it? Or is it just going up and down regardless? Almost looks like it's just going up and down regardless. No, it's staying pretty low when I don't talk. It's definitely going up when I do talk, yeah. It's definitely going up when I do talk, so it can hear me. And I guess I realize y'all can't see this. Let me do this. Let's scoot this back, go to here. And just to show for sure this is going up, I'm going to stop talking and I'm just going to tap it. So it's going a little fast. Let's try 5 times a second. Yeah. When I tap it, we start getting bigger values. When I don't tap it and when I don't say anything, we get smaller values. So it looks like don't know what the range is going to come out between. Does the guide tell us? So this is actually plotting it into mu. Data pin, clock pin, magnitude. So normalize, this is what it's calling. Summing everything, taking the square root of sum over the values. Min buff. So I'm not actually sure what the maximum would be. Got it pretty high there by blowing on it. 20,000. We peaked at 20,000, but most of the time, really, we're down more closer to like 15, between 10 and 15. So let's use that simple IO thing. Simple. And then let's say no longer print this. So the value, magnitude, the real range, 0.0 up to, let's call it, let's say 18,000. Call that the maximum. I know we got a couple values over that, but it seemed pretty rare. And then the new range we want is 0 to 1. Yeah. No module. That's a library. Circup. Did it again with the X. Okay, there we go. Oh, it rebooted. See here? Talking towards the thing. Those numbers are getting a little bit bigger, but they're still pretty small, all things considered. Truthfully, maybe we should make our range a little bit lower so that we can actually see some bars get drawn. If I blow on it, it goes pretty high, but I think I'd like to see it change while I'm talking. So maybe we'll lower this down. Maybe we'll lower this down some more. I'm going to put this print back on, turn this print back off, and then I'm going to look at some of the values while I'm talking. So right now, I'm talking into its direction. We're getting up to 100 to 200. I saw a couple over 200. There's a couple more over 300. Looks like I'm not seeing too much taller than that, about 300. So why don't we try making that our range. Let's turn this one back off. Let's turn this one back on. And let's say 300. So if we were to blow in it, we would go way off the top end of the scale. But if we stick to just talking, we should now be getting a pretty good range, you know, between 0 and 1, which it looks like we are. So I'm pretty happy with that. Now we're floating right nicely between 0 and 1 while I speak. So that's pretty good. So now we could take this value we got here and put it into the bar graph. So we can say relative value is this. We could print relative value, and we could also bar graph.show relative value. So I'm going to put this back here. I'm going to put the camera back. Show the actual clue there. And it should be working, I think, right? So I'm going to make this a little bigger. I'm going to save this to get it to run. And here we go. So now we have a sound bar graph. And as I talk, the sound gets louder, and therefore the graph goes up. You can see it peaking at the top there when I speak very loudly. If I stop talking altogether, the graph will stay very low down at the bottom end. The other thing is we probably have a little bit of leeway. We could maybe get away with not quite so slow. Let's try making this update faster. Okay, so here we have no sleep, and yeah, that's responding much faster, and it looks a lot like an audio, you know, visualizer that you would see on a stereo or something like that, where it's bouncing with the audio levels as they're coming in. And that's a really cool effect. I'm actually pretty happy with that. I think that looks really nice. And it kind of floats there down towards the bottom when I'm not speaking. And there's a little bit of ambient sound in this room, like my laptop fan is kind of loud. I think maybe the heat is on as well, so that's making a little bit of sound. So that does explain why down at the bottom end of the scale there, we're not going too low. I think, yeah, my camera actually is having a little bit of trouble keeping up. But the screen itself on the clue is actually jumping pretty well. Pretty much in real time. Honestly, it looks a lot like what it's intended. You know, it looks like the actual physical component that does this. Not sure why the camera is all of a sudden getting a much lower frame rate. We were good there for a minute. It's kind of perplexing. Let's refresh this. Yeah, now we're back to a pretty good frame rate here. So I don't really know what that was all about, but the actual widget on the screen stayed nice and snappy the whole time. It was always bouncing just like this, looking really good with the peaks of the audio and everything. So I think the widget itself is good. That was just my camera kind of slowing it down a little bit. And this is really awesome. This is another really good widget. Maybe we can, what if can we record a quick little clip of this maybe? Is this peak? Let's try this. This is a clue example using the microphone built into the clue with Cedar Grove Studios' new bar graph Displayio widget. Let's save that. I don't know if this is going to have sound in it. I don't think so. Not actually sure though. Yeah, I don't hear any sound. Okay, perfect. Yeah, I don't necessarily need the sound to go in it. I mostly just want to show off the widget itself. But I'm gonna actually paste this in the show and tell room. I guess I'll use my other Discord window. We'll leave this one because that's the one that drives the chat on the stream there. So we'll go to this one instead. Still need to figure out how to turn the chat on YouTube off. That's something I've been meaning to do for a couple of weeks now. Oh, somebody doesn't like one of my videos. That's all right. Not for everybody. That's fine. Let's close that. And we could close this now. How big is this? It should be pretty small, I think, right? Here we go. All right. Now, too many of these. Only, yeah, 2.9 megs. Not too bad. I think Discord can handle that. Let's open. That's what I would like to do. Open. Thank you. Here we go. .560. I think 560 also is working on the Raspberry Pi fork from Scott's that he's been working on in his streams. Dexter, it looked like Dexter got that running as well. I'm gonna go to show and tell. I haven't looked through here for a few days, so I'm gonna take a quick scroll through. Ooh, that's a funky looking screen. Oh, okay. You can't see it unless you have the right lens. That's pretty cool. I'm just gonna take a look through these. I always like to scroll through show and tell, see what folks are working on. It's just been a couple of days since I've done it. Got a nice stack of Pi Zero stuff there. Oh, I did see a picture of this. I think this was in the newsletter, maybe. Or maybe I did see it here. I don't remember where, but this looks really, really cool too. They used Displayio to mimic like a some kind of old analog display. It looks really cool. It's kind of similar to some of the stuff that Cedar Grove is making, honestly. What is this? Bigger lever. Okay, got a robot from SparkFun there. Huh. It looks like this is using an Xbox controller, maybe? Sending the inputs into the computer. And then eventually it must be going on to a robot. Maybe this is just the debug from the robot. Maybe it's sent it directly to the robot, not actually to the computer. Looks like this person made a Google Glass, basically. That's pretty sweet. This is a double tall stacked printer. Sure is. That's pretty cool. Wonder what this QR code goes to, kind of. That's a nice little basic table there, made out of 2x4s and stuff. It's like plywood, maybe inch plywood on the bottom, 2x4s around the outside, posts coming up from the corners. And then the top is basically, it looks like just another one of the thing on the bottom, but turned over. Looks like the top is the same, like, piece, just flipped over. That's a neat little table. I like that. I've never been, never done too much woodworking. My father's done loads and loads of woodworking. He's got a whole shop and all kinds of tools for that. I kind of look at it as I got his same knack for tinkering, but my tinkering tends to be virtual in the computer, whereas he's usually making more physical widgets, either wood or other kind of objects. Volume down. Okay, so this is the this is from that Pi camera. So it's got a camera on the front of it, I guess, and it's able to like beam back a video of what the person is seeing, essentially. It's not like a Google Glass exactly. It's not. I don't think it has a screen built in that you look at here, but instead the idea is just to record whatever you're looking at, or stream it or whatever, right? Just get the video from it and do something with it. Oh, this is cool. I don't use VS Code, but it's a cool idea to have the serial plotter. I assume it's similar to the one in Mu, like how you can go to the serial graph and it draws that line graph, like we saw the example of the sound a minute ago. Inexpensive lupe. I guess this looks like a jeweler's magnifying thing. I'm not familiar with this term, but I guess that's what this means. Looks like they added the NeoPixel ring down inside there to give it some extra light. Looks like we got a macro pad. Turn it into a calculator. Nice. Looks like they're mimicking this specific HP 35 RPN. Oh, it's running as an emulator inside there. It's not just a CircuitPython program that implements a calculator. Is that right? It's actually emulating the whole... Yeah. Wow. Okay, this is, looks like the inception of this project. So this is an emulator of the calculator. But this one obviously is not Arduino. This is implemented in, I guess, probably JavaScript and HTML, since it's inside a web browser. Other things it could be, I guess. Yeah, JavaScript. Okay, so somebody made a JavaScript simulator. This person then re-implemented it in Arduino instead of JavaScript. And then this person that we just started looking at here took that Arduino re-implementation and changed it up to use physical buttons on the macro pad instead of the virtual buttons on the screen, like the Arduino was doing. Nice. Yeah, this is really cool. I never used one of these specific calculators, I don't think, but this is a really neat project. I love the idea of kind of bringing that emulator to more platforms. The JavaScript emulator is pretty cool by itself, but moving that over to Arduino, the little touchscreen, is super awesome. And then taking it the next step further and bringing it over to the macro pad is also really cool. It's like a little alarm. Pulls data from the website, checks it, adds it to the schedule, tracking 5 minutes, and then email if the alarm was canceled. Uses the voice bonnet, so you can record probably the sound that it plays. I got my sound off, so I'm not hearing it, but I guess it's probably making sound right now. Maybe talking or something. Couple more pics of the camera. Yeah, so there's the Pi camera pointed outward from the glasses there. That's pretty sweet. I think they said it was a Pi 0 2W, so it's probably stacked with this. Ooh, Mad Eye Moody. I'm always down for some Harry Potter cosplay stuff. Nice. It's a good looking eye. Let me pull this over. Nice, okay, so this person worked with Scur to make this. You know what this reminds me of is the I code that's in the Monster Mask. Wonder if that's where they got the code originally. Or if this is a new implementation. Sweet. It's pretty cool looking. Got another video of it. Can't pause this after it starts. Oh, there we go. It paused when I clicked it again. It just doesn't have any icons. Icegoat 9 got a Pi Gamer. Made solitaire poker. Nice. Doesn't show any of the actual gameplay, but it looks like a really cool project. Giant key switch. My wife has one of these. Big old giant clacky switch. Oh, that's a nice looking container. CO2 monitoring. Got a really nice looking 3D printed case for it. Looks like probably the battery plugs in with a little JST or something as well, so you can maybe have 2 batteries and swap it out, you know, for one charging and one running. This is interesting. We got a D-pad and 3 buttons. It's interesting, this little kind of concave area here. There's a giant functioning switch on. Is this the same person that posted this? It is. So this top part is for the giant switch. I bet you this big old, and this thing is big, like this picture doesn't make it very clear. See if we can find one with something for scale. Clack, this is just the thing by itself. The Big Switch series by Novel Keys. Novel Keys, Clack, Big Switch. So this has a regular cherry for scale. This is a regular cherry like keyboard key size thing, and this is the big one. So then this cutout at the top here can fit that big one. So that can be one of your buttons on your macro pad. That's pretty cool. Porcupine. Looks like a little comb with a bottle opener as well. Maybe something else under there, like you could use it for a wrench maybe. Oh no. Nice. Revived it. Flushed the bootloader back onto it. Yeah, these little things are pretty resilient. I mean, it's still possible to brick it. You do things, you know, just the right way or just the wrong way, I guess, but the majority of the time you can get it back if you have a, oh, what do they call this? Little programmer. I forget the name of this thing. Basically, you can rewrite every part of the device, though. You can rewrite the bootloader if you need to. Huh. That's a neat little trick. Looks like it spins or something, maybe. It selects a random cup, so you could fill up like different drinks or something, and then shots, it looks like, I guess, right? It's probably sized for shot glasses. Fill in different shots, and then it will randomly select which one gives you. Oh yeah, there's the macro pad with the giant switch. All right, we're almost caught up now. We have like a button or a keypad or something. Keyboard, I guess. Keyboard. Stick a keyboard on there. Not sure what this does. This is some code. 8-bit composite. Custom power supply. Always like to see those. A nice looking one. Looks like they used folded sheet metal. Maybe for the main body. Very nice looking. Oh, they asked. Got it off Amazon. Okay, so it's probably not folded sheet metal, it's aluminum, so it's probably just cut and manufactured and stuff that way, right? Nice. Nice little case though, for sure. Nice. All right, and that catches us up. So I'm gonna paste this video here. I think I'm probably gonna wrap up after that as well. I'm gonna try to, this weekend is Hackaday Remoticon. So if folks, yesterday was the first day, today's the second day. I think it's only 2 days, so I think today's the last day. I'm not sure what time everything is going on, but there's bunch of talks and other festivities going on, so I'm going to try to catch some of that stuff today. So I'm going to cut my stream off a little bit early here. I do want to paste a copy of this though real quick here. Let's go. Oh, it doesn't want to do that. Maybe we go drag drop. Yeah, there we go. Now let's mention some stuff here. Huh. Oh, it's on here there's C Grover, yeah. Or graph, did I spell that wrong? No, it just wants it 2 words, that's fine. Cool. Oh, what happened there? Go. Nice. That looks really cool. I really like the way this one turned out. It looks a lot like a little analog light volume sensor thing. That turned out really nice. And the code to do it is so simple too. It's not really complex at all, right? We just initialized the bar graph. We gave it 2 units, so it'd be twice as long. And then really all we had to do is just get our value from the microphone, map it to 0 to 1, and then send it right into the bar graph. That's all there is to it. Turned out really nice. All right, folks. So I'm gonna wrap it up here. Thank you to everyone who tuned in. Dexter, I think, left a little while ago, but thank you to Dexter as well. I will be back at the normal time next week. Saturday mornings at 10 a.m. Central Time is when I stream. So that was about 2.5 hours ago is when I started, and I start at that time normally every Saturday and do a stream similar to this. You know, we always work on different stuff. Sometimes I will be working on existing libraries. Sometimes I'll be taking a look at other people's work like we did today. All kinds of different stuff that I work on. Just depends on what all is going on at the time. But if you found this interesting, again, you can find me again next week, Saturday morning, 10 a.m. I think Scott mentioned that there's no deep dive on Friday. So I might stream Friday night. I don't really know what my schedule is like yet. I think this is Thanksgiving week, so Thanksgiving is on Thursday in the US or anywhere else if they celebrate Thanksgiving. I'm not actually sure, honestly. I'm a little ignorant to that, but certainly in the US Thanksgiving is on Thursday, and so then Friday is like not exactly a holiday, but kind of become a holiday. Lots of folks have it off of work and stuff like that. So, but if there's no deep dive and if I'm not doing anything else, then Friday evening I may stream as well in the normal time slot where deep dive is at, just because I usually would be watching deep dive. So if it's not on, then I may as well stream as well. So maybe we'll do that. I'm not 100% sure. I'll try to figure out if I can ping deep divers. I had trouble with it last time around, so I might not be able to ping that role, but I'll definitely, mention it in the live broadcast chat room on Friday if I am going to do it. So keep an eye out there if you want to watch along on Friday when there's no deep dive, since Scott's not going to go on Friday. But Otherwise, yeah, check out Remoticon if you're interested. Again, there's all kinds of cool talks and stuff. That's what I'm headed to do now. So, yeah, thanks again, everybody, and I'll catch you next time.